All right, here we go. We're going to try to finish this up. I thought on Friday, I kind of alluded to the fact that we had done 45, 45, 90. We're going to do 30, 60, 90, but they do not include it in this lesson. I thought for sure that's kind of usually what they would do. They go from 45, 45 to 30, 60, 90, but I'm just going to do what they have us do. So let's go right to example 4. So, all right. It says find the values of the 6 trig functions. So again, we are writing all the trig functions, but they give you something a little bit different here. Let's do a little x and y axis deal. And they tell you, says you want to find the values of the 6 trig functions for an angle theta. Okay, we don't know the angle this time. Before, we knew it. We knew 45 degrees, 90 degrees, 135, 315. Remember all those that we did? 225. Those were all kind of combinations of the quadrantal angles, the 0, 90, 180, 270, and all the ones that had 45s in them. All right. Like I said, I thought for sure they would go to the 30s and the 60s in there, but they didn't. So I'm sure they'll do it another time. But this time we don't know what the angle is. All right, but they do tell you a couple sides. So let's show you how to do this. It says for an angle, find the 6 trig functions for an angle theta in standard position if a point with coordinates, and they give you coordinates, lie on its terminal side. So what they're going to do is they're going to give you some coordinates, and what you have to do is find the sine, cosine, tangent, and the inverses of that angle. We're not really finding the angle right now. We eventually will find what that angle is. Okay, we're not doing it right now. They're just kind of working you up to that. All right, so today they're just trying to give you some ratios, sine, cosine, and tangent, cosecant, secant, and cotangent of that particular angle. So the point that they give you is 5, negative 12. So they give you a point, 5, negative 12. So the first thing we're going to do is plot that point. It really doesn't have to be that accurate. It doesn't make really that much difference. So I'm going to go over 5 and down negative 12. It'll be around in here somewhere, okay? You don't even have to have graph paper for this. This is just a good idea to have a frame of reference, okay? It's just a good reference to have, all right? So what I'm going to do is I'm going to draw up a line segment from the origin to that particular point right there, which is what? 5, negative 12. Now, here's something that's super important. We're going to make a right triangle out of this. But I am always, can I say always? Pretty much always. I'll say that. Just hedge my bets a little bit. Pretty much always. What we're going to do is we're going to make a right triangle, but we're not going to take it over to the y-axis. You follow me? I mean, that would make a right triangle. Almost every single time, I can't think of any other time where we won't do this, but so every single time, as far as I can remember, we're going to take this up to the x-axis to make a right triangle out of it. Everybody hear that? Doesn't matter where the point is. The point could be here. How are we going to make that right triangle? Take it to the x-axis. If the point was here, we would take it down to the x-axis. Everybody got that? So I'm going to take this up to the x-axis and make a right triangle out of it. I got to click off of that first before I start writing on it. So I got a nice little right triangle there. Now, I know a couple of my sides, don't I? I went over how far? This is the point 5, negative 12. So what is the length of that part of the triangle, that little side right there? It's 5. That's right. That's 5. And then, what's the length of that side right there? Okay, it is negative 12, but just the length of it. I'm just worried about the length of it right now, but it is 12, okay? And we will consider the negative, okay? I'm not discounting that, all right? But the length of it is 12. Again, what am I trying to do? I'm trying to find the 6 trig functions, okay? I want to find the sine of what? This angle right here. That's the key to this, all right? So if you take it up to the x-axis, all this stuff works out nice and pretty, all right? So I'm going to make that theta right there. So what I'm going to do is find the sine of theta, cosine theta, tangent theta. Then I'm going to do the inverse, okay? Just flip them, the secant, or the, whatever, cosecant theta, secant of theta, and the cotangent of theta. That's what I'm doing. Because it's always the one with the x-axis. All right, because remember, this is my, what do they call that? I know the last one's the terminal side, the initial side, I think maybe. Is that what they called it, the initial side? Anyway, you always take it up to the x-axis. All right, that was the key to this. Remember, I kind of harped on that a little bit earlier. Take it up to the x-axis. This right here is my angle theta. It's always from wherever that diagonal goes up to, put a little arrow there, up to the x-axis. It's not this one down here. That changes, that reverses everything. All right, if you do it this way, makes it really nice. I'm missing one thing. So I'm going to go like opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. What am I missing according to this angle right here, theta? That's my opposite. That's my adjacent. I'm missing the hypotenuse. So I got to find the hypotenuse. How do I find the hypotenuse? Say what? It's not a 45 degree. We don't know it's a 45 degree. Well, I know for a fact it's not 40. How do I know for a fact it's not a 45 degree angle? Well, it's a right angle. It's not obtuse. Because these two sides would be equal to each other. If this was a 45, 45, 90 triangle, these two sides right here would be the same. Are they the same? No. So is it a 45, 45? No, it's not. But somebody said it earlier. We use a little thing in geometry. Pythagorean theorem, right. We also had some things called the Pythagorean triple. Do you remember the smallest, easiest Pythagorean triple? 3, 4, 5. Well, this is one as well. Maybe you don't remember it, but I'm telling you, it is. It's a 5, 12, 13. Okay? If you didn't know that, that's fine. Perfectly fine. You could do the Pythagorean theorem and find it. Let's do that and find it. All right, so we'll just go like this. 5 squared plus 12 squared equals what? C squared, we'll call it. All right, that's 25. That's 144. That's 169. Take the square root. Square root of 169 is 13. So it is. It's 5, 12, 13. But it's kind of nice, right? You guys, well, let's see. Last year you took a PSAT, right? You're going to be taking the SAT this year, right? You're taking it sometime. You've already had it? Okay. You never know. Listen. Shh. Hey, stick with what we're doing here. You never know. You might have a situation. There was a couple times I taught a SAT prep class way back in the day, and I'm sure the tests are maybe a little bit different, but this came out to be pretty helpful, all right? Instead of having to go through and do the Pythagorean theorem and waste all your time, and you know time is very precious on the SAT, right? So if you looked at this, you could say, oh, that's 13 without even doing any math at all, if you understand your Pythagorean triples, if you know them, all right? So that could be, it could save you how many seconds? 30 seconds maybe? Something like that, but you never know. 30 seconds could be helpful. So we're going to put a 13 in for there. So what are we trying to do, though? We're trying to find the what? The sine of theta. I don't even know what theta is. I don't even know what the angle is, but I don't care. I don't need to know it because that's not what they're asking me for. Like I said earlier, eventually they will ask you to find that angle. It's actually pretty easy. I could show you right now, but I'm not going to. All right. I just want to find the sine of the angle, the cosine of the angle, the tangent of the angle, and what are my inverses? What's the inverse of the sine? The cosecant of the angle. The what? The secant of the angle and the cotangent of the angle. Now, once I find the sine, cosine, and tangent, I can very easily find these three, can't I? What do? I just flip them, okay? So what's the sine of this angle? Sine is the what over the what? Opposite over the hypotenuse. So what's the sine? 12 over 13. That's all they're asking you to do right now, okay? They're leading you up to something later, but right now they're just asking what the sine of that angle is. What's the cosine of this angle? It's adjacent over hypotenuse, so it's 5 over 13. The tangent of this angle is the opposite over the adjacent, or 12 over 5. Everybody got that? Oh, sorry, my bad. I said this earlier and I forgot it. That is a negative 12. You do go down negative, all right? So anything with the 12 in there will have a negative. Sorry about that. Cosine, though, is not negative, is it? Okay? Now, what's the cosecant? The cosecant is just the inverse of the sine. So instead of negative 12 over 13, it's what? Negative 13 over 12. So that's super easy to find the inverses once you find the first ones. Secant's the inverse of the cosine, so it's going to be 13 over 5. And the cotangent is the inverse of the tangent, so that's negative 5 over 12. So if it had a negative, it's still going to have a negative. All right? If it was positive, it's still going to be positive. We just switched the top and the bottom. Make sense? Yeah, it's pretty easy, isn't it? And that's pretty helpful, okay? This can be very helpful. Let's do another one. It's kind of the same, I think. And we're going to have some time, so maybe I will talk about the 30. Yeah, I think, let's see, when do we do that? I know I did a whole list with the 30s and the 60s. Yeah, I do it on 5-5. Let's just wait till 5-5 till we get there instead of doing it now. I want to overwhelm you too much. All right, let's do one more. I don't know. What did I say it's on? Quiz is 5-1 to 5-3, so up to this stuff. Up to this, okay? So I got one more to do. And that's it. It's pretty easy.
Would the following students please go to room 105 immediately? Logan Hill, Judah Johnson, Akira Linton Patrick, Emma Nichols, Abby Sowers, Danae Simmons. Thank you.
See, it's not what you thought it was, I would guess. At first, you might have thought it was a bad thing, but with those other names, I don't think it's that bad.
It's a bad.
It is a bad thing with those other ones that are in there?
No, they have a sub.
Oh, goodness. All right, here we go. You ready? It's a lot to write out. It's in your book if you want to look. It's example 5 as far as what they're asking you to do. It just take me too long to write it all out. I wrote it out on my notes, but I'm just going to read it to you. It says, suppose theta is an angle in standard position, all right? Meaning from here, it's either going to go out like this, out like this. Everybody see that? Okay, that's standard position. It says, whose terminal sides lie in quadrant 3. All right, where's quadrant 3? Top right, top left, bottom right. Which one? Quadrant 3? Top left? Quadrant 3? Bottom left, yes. Bottom left. 1, 2, 3, okay? Right? 1, 2, 3. So it lies in the third quadrant. Now, this is a little bit different. It's very similar to what we did just a minute ago, but it's a little different. It says, if the sine of theta is equal to negative 4 over 5, find the values of the remaining 5 trig functions. All right, there's 6 altogether, right? The first 3, sine, cosine, tangent. Then there's the inverse ones. They give you one of them. They tell you the sine is negative 4 over 5. So they don't tell you exactly like where that point is, do they? But they do tell you it's in the third quadrant. So what is the sine? It's the what over the what? It's the opposite over the hypotenuse. So watch. I really don't care where I put that terminal side. Okay, I'm just going to put it somewhere in here. Okay, you could say, okay, negative 4 or 5, whatever. I'm just going to put one here. I don't care. All right? It doesn't matter. As long as you're in the third quadrant, you're good to go. You don't have to be that particular. And then what am I going to do? I'm going to drop this back up to the x-axis. Everybody see that? All right, so there's my angle, right? There's my angle right there, or this right there, however you want to look at it. There's my angle, and I made a right triangle out of it. And what is this? The sine is negative 4 over 5. Now, this one, we'll never call this either positive or negative, this slanted one, all right? So the negative, because you could write this 4 over negative 5, couldn't you? All right, but what we're going to do, how should I say this? Yeah, the 5 is the hypotenuse, okay? So I'm not going to make the hypotenuse a negative, okay? It's always going to be positive, okay? It's the other two that could be negative and positive, all right? You with me on that? So what do? We start here, or here's our angle. We don't know what it is. It's theta. And so what's the opposite? What's the hypotenuse? Well, the opposite would be what? -4. Do you see that? See how the opposite is -4? So what is this length right here? That's -4. What's the hypotenuse? That would be 5. You with me on that? Because if you made the 4 a positive, it wouldn't be in the third quadrant, would it? You see that? So because it has to be negative. All right, there you go. Here's another example of where we could use a Pythagorean triple. If this is 5 and that's 4, what is it from here to here? It's not just 3. Which direction are we going? We're going to the left, aren't we? So this would be what? A -3. Now, they don't ask you this, but what would this point right here be? Pretty easy. It's right in front of you. What would that point right there be? If you start here and you got to get to this point. No? This way? This way.
Oh, -3, 4.
Yeah, well, you almost got it. Hannah, what'd you say? Come on. How do you get to this point right here? Thank you. -3, -4, right? To get to a point in the third quadrant, you got to go negative. Yes? Positive here, positive here, negative here. Yes? All right. So anyway, they don't ask what that point is, but it's kind of nice to know. What if they give you weird numbers and they weren't a Pythagorean triple? How would I find that length right there? Just do the what? Pythagorean theorem. Right. Just do Pythagorean theorem and figure out what that is. Because sometimes they do. Sometimes they're going to be the square root of 17 or something weird like that. Okay? So sometimes you're going to have to do that. With these, they gave me Pythagorean triples, which just made it kind of nice and easy. So what do they want you to do? They want you to find the other trig functions, right? We already know the sign. They told us that one right off the top. What was it? -4/5. What do we got to find now? The cosine of theta and the tangent of theta. And then we got to find the cosecant of theta, the secant of theta, and the cotangent of theta. Everybody with me on this? This is what we're trying to find. It says, I didn't write it down because it's too much to write, but it says find the values, or it says suppose that is in the third quadrant, that angle is in the third quadrant, and then it says find the value of the remaining 5 trig functions. So there's the one they give you. Here's the remaining 5. All right, so now we got it set up for us. I don't know what the angle is. Okay, I really have no idea, but I don't need to know what the angle is. All I got to find is the sine, cosine, and tangent of that angle. All right, what's the cosine of this angle then? It's the adjacent over the hypotenuse. So it's going to be what? -3/5. What's the tangent of this angle? It's opposite over adjacent. So here's opposite, here's adjacent. What is that? +4/3. Right? It's negative over negative, which is a positive. You guys getting this? Yeah, it's not too hard. Cosecant. Do I have to go over here and say, well, the sine is opposite over hypotenuse, so now I'm going to do the hypotenuse over opposite? No, you already got the sine, so what are you going to do with it? Just going to flip it. 5/4, and you could put the negative on top, you could put it in the middle, you could put it at the bottom. It doesn't matter. It's just a -5/4. All right, what about the secant? You just flip this. So it's a -5/3. And then cotangent, you flip that, it's just 3/4. And that's what they ask for. That right there, all that stuff in yellow, that's your answer. There's no simplifying. Just leave it like that. That's simplified. It doesn't reduce, right? There's no solving. You don't have to find theta. Eventually you will. Not today. All right? All you got to do right now is just find what the sine, cosine, tangent, and their inverses are equal to. Pretty easy, isn't it? Couple keys. I'll repeat again. It says in the third quadrant, so you just draw any line segment, any terminal side, okay, in the third quadrant. Doesn't matter if you're if that looks smaller than that or that's bigger than, it doesn't matter. All right, just somewhere in here. I just want to see what my three sides are, and then I just want to know what my opposite, my hypotenuse, and my adjacent are. That's really all I got to do. The signs make a difference. So if you're in the third quadrant, you are going negative, negative. All right, so that's important. And that should be good. What do you think? You good? Do we have too much time left over? Will you? Is the question. I don't mind. For years and years, I had my classes start early because it used to be my classes would get on it right away and work really hard. They'd ask me questions. They'd ask other student questions. But man, the last several years I've been teaching math, that just doesn't seem to work. I would love to give you time to work in class. So if you can promise me you're actually going to work in class, then you can. Did I give you any assignment on Friday? All right, so I'm going to give them both to you. And you got 20 minutes, so that'll be good. I broke it down. Let's see. Oh, okay. I'm going to give you some today and some tomorrow. So wow, 2 days to work in class. What am I thinking? That's all right. We'll see if it works. So it's section 5.3. We're going to do A and B. All right. So section 5.3 is 14 to 35. 14 to 35. And then here's what I'm going to do tomorrow, what you're going to do tomorrow, is 5.3b, and it's 38 to 44. Okay? So those are two separate assignments. Do them on two separate papers. Tonight, get this done. And then tomorrow in class, we're going to go over this, 5.3a. I'm going to give you time to work on 5.3b. And we're going to do a brief review for a quiz. And the quiz is on what? Wednesday? And it's 5.1 to 5.3. 5.1 to 5.3. Everybody good? Yeah. Oh, okay. Oh, you know what I did? If yours, Brooke, I did this for you especially. Not this week's lesson plans, but last week's lesson. Can you get to last week's? It'll let you do that, right? Who can get on RenWeb with your facts thing? Get on there, bring up the homework thing, and well, just go to 5.3. Just flip to the back and you'll see it. So go to the last week's lesson plan? Okay. Yeah, if you go to last week's lesson plan, I believe on Friday of last week, if you go to lesson plans, I put a link to the Google Drive with the book on there. Okay? So go to that and do what I ask you to do. Download it to your phone. It's a little bit bigger of a file for a PDF, but it's not super big. I forget what it is, how big it is. But, I mean, it's probably way less than a couple pictures that you might take, I think. I don't know. Let me close this.